to learn about Dijkstra algorithm. Dijkstra is one of the important algorithm and this can be asked in the interview. Dijkstra is a single source shortest path algorithm. This algorithm is used to find the minimum distance between two nodes in which a particular node is fixed and we find the distance from that node to all the other nodes. Here in the given picture, the source node is taken as the node 0 and the motive is to find the minimum distance between the node 0 to all the other nodes. Here we can clearly see that the distance between the 0th node and the 1 node is 4. And similarly, the shortest distance between the node 0 to node 2 is 8. And if you talk about the minimum distance between the node 0 to node 3, there are two paths to reach the node 3 in which the path which shortest distance is 10. So we reach the node 3 from node 2. Similarly, the smallest distance between the node 0 to node 4 is 10 by reaching via node 1. So this algorithm is used to find the minimum distance between two nodes from the source node to all the other nodes. To use the Dijkstra algorithm, there should be no negative cycles in the entire graph. It means the distance traveled will always increase by adding the edges. Distance will keeps on increases on adding further edges. This is the key point on which the entire algorithm is based on. And the Dijkstra algorithm will gives a spanning tree. Time complexity of this algorithm is E into log V, where E represents the number of edges and V represents number of vertices. And V equal to number of vertices. And the space complexity is E plus V. Now, implementation of Dijkstra algorithm is mainly done by using a visited array which keeps track of every node whether it is visited or not. and a priority queue. Visited array maintains the status of each node, whether it is visited or not. And the priority queue gives the next smallest path forming edge from the from all the visited nodes, which is not traversed until now. For example, if we consider the graph given below here, first we know the distance between the source node to source node is always 0. So we push the source node 0 with a distance of 0. Then here we have two adjacent nodes connected with this source node. So the priority queue will push both the edges into the priority queue. The priority queue will return the node 1 as the distance between the source node to the node 1 is less than the source distance between the source node to the second node. So we'll traverse the first path from 0 to 1. Now here we have two nodes visited, node 1 and node 0. And again we'll push the node 4 as it is now a new adjacent node of this current spanning tree. So we'll compare the distance 8 and 6. The 6 is smaller, then we again take the we take the node 4. I'm sorry. We compare the sum of the distances. Like here, if we take the 4, the total distance is becoming 10. Whereas if we take the node 2, the total distance is 8. So we take the node 2 and make the node 2 as visited and push the node 3 into the priority queue. Now we'll again compare we have two nodes in the priority queue. One is the node 2, node 4, and other is the node 3. If we take the node 3, then the total distance is 10. And if take the node 4, still the total distance is 10. So we can take any node. After taking the node 3, the node 4 will also be made as visited. Since therefore the final spanning tree is going to be like this for this given graph, which gives the distance between the shortest distance between the source node to all the other nodes. Let's write the implementation of the Dijkstra algorithm in the GFG. So here in this function, we have to write the entire algorithm of Dijkstra. We have given the number of vertices v along with the edges of the graph and the source node whose shortest distance we have to find. So we'll first of all we'll create the adjacency list for this graph. Let's traverse all the edges and push it into the adjacency list. Adj of u, like edges of I of 0 dot push back edges I of 1. And similarly, since this is an undirected graph, we are pushing the edge for both the nodes. Push back edges of I of 0. Here in this way, we have created the entire adjacency list. Let's initialize a priority queue. Since the priority queue has to return the smallest distance, we are making a min heap whose syntax goes like this. And each node in this priority queue will store two values. One is the distance and the other one is the node. So we're creating a, I hope you know this way of initializing a min heap. In this priority queue, the first node that we are going to push into the queue is the source node with distance 0. Okay. The first value of the priority queue means each node of the priority queue maintains the distance between the source node to the current node. We'll initialize two vectors. One is the distance array, which gives the final distance, minimum distance between the source node to all the other nodes. So we'll create a distance array of size v along with a visited array of size v. Now, the moment we got a node from the priority queue, we'll make it as visited. Top is equal to pq.top. We'll make that node as visited. It means visited of top dot second is equal to 1. And we'll pop the first element pq dot pop off. Now, once we visit a node, we will push all its adjacent nodes into the priority queue. So we are going to traverse the adjacency list of that node. Top dot second dot size of I plus plus. If a child node, like adjacent node of my current node is not at visited, it means its visited is 0, then we'll push that node into the priority queue with a distance of top dot first plus the weight of that edge. Unfortunately, we have not maintained the edge, so we're making the each element of this adjacent list as a pair which stores the edge weight of the element. Edges of I of 2. Here in this way we have maintained the edges along with that node. So we are going to add the distance of the current node plus edge weight of the child node, that is adj also dot second dot second of I dot first. Let's also push that node, that is adjacency list, this entire. So here in this way we have added all its adjacent nodes. Let's check our code. It told us to return a vector, so I'm making the distance array to vector, and let's return the distance vector. Let's see if we done any mistakes in the code. We initialized an adjacency list. We have added the edges into that adjacency list with each node consisting of two values. One is the edge weight and the other one is the node. Then after we created a distance array vector which maintains the distance from the source node to that node. Then we have maintained an array which maintains whether the array node is visited or not. Here and is nothing but v. And then we have initialized a priority queue which gives the minimum edge and I hope the entire code is correct. Let's run this code and check if any comparison errors we have encountered. I corrected some compilation errors here and there, and I just added a small condition that the upcoming node is already visited. Then I'm just popping that node and skipping that iteration, going to the next iteration. So this is all about Dijkstra algorithm, and I hope you like this video. And if you like this video, please do subscribe to our channel and share this video to your friends. Thank you for watching.